In this lesson, you will learn about the risks posed to aircraft by collision with birds, and the methods and procedures which have been developed both to minimise the likelihood of bird strikes and to make pilots aware of the types and locations of potential hazards. Since aircraft started to share the air with birds, the risk of collision has existed. The first recorded bird strike happened in 1905, when Orville Wright, whilst practising flying in circles, chased a flock of birds and killed one, which fell on the upper wing but fell off after a while when he banked more steeply. It is not recorded which was travelling faster, the bird or the Wright flyer. The first human fatality occurred in 1912, when pioneer Cal Rogers was drowned after a gull jammed his control cables and his aircraft crashed into the sea off Long Beach, California. The risk has grown greatly with the increase in civil, military and private aviation activity, and particularly commercial flying, since the end of the Second World War. However, statistically, only a very small percentage of bird strikes result in human fatalities, and only about 10 to 15% cause damage to the aircraft. It is difficult to be exact about these figures, as many minor bird strikes go unreported, or even unnoticed. Bird strikes can inflict structural damage to airframes and engines to the extent of causing power loss or even engine failure. Jet engines are particularly vulnerable, having large intakes and rows of fan and compressor blades. A bird strike on a windscreen or on the nose of the aircraft, even if it may cause no physical damage, will probably deposit bird remains, obscuring pilots' vision. Prevention of bird strikes can be greatly helped by knowledge of bird habits, especially migration routes and seasons, and by observation of concentrations of birds near airfields. Such observations can be passed to air traffic control units, who can relay warnings to other aircraft. On a broader view, prevention can come into two categories: either keeping the birds away from the aircraft, bird management or control, or the aircraft away from the birds, aircraft flight path management. Bird management can be achieved in several ways, and airfield managers can select the measures which best suit their location and situation. Ways of reducing an airport's attractiveness to birds as a habitat could include reducing roosting sites such as groups of trees and eliminating sources of food, for example, seed-bearing grasses, bushes, or shrubs with fruits and berries. Trials have also shown successfully that leaving grass long on airfields will deter birds from landing in large numbers, as short grass makes for easier landing and a better view of any surface or airborne threat. Rubbish tips and landfill sites are very attractive to birds, particularly seagulls, and therefore their location near an airfield would create a significant hazard. Noise and lights can also be used to scare birds temporarily and encourage them to stay away. Bird control units, mobile air traffic control, or airport fire service staff can use pyrotechnics or loud broadcasts of bird distress calls. However, birds do become accustomed to these disturbances, so a change of method may be required from time to time. Successful use has also been made of dogs, particularly border collies, a widely used sheepdog breed, and of birds of prey, which are a very good deterrent to many species of birds. If it is not practical to try to move the birds from an area, for example in the case of a coastal airfield, then flight paths can be adapted to avoid the birds as much as possible. Departure routes will normally be designed to avoid known bird concentrations, and noise abatement procedures have the added benefit of a rapid initial climb, since most bird strikes occur below about 3,000 feet. It is interesting to note that on migratory routes during the spring and autumn, when bird transits are at their height, the number of bird strikes above 500 feet is much greater at night than during daylight. Use of aircraft lights can help birds detect and avoid aircraft in this situation. When birds sense a threat or approaching object, and this is usually by seeing it, they will tend to evade downwards, so pilots should be prepared to pull up. The kinetic energy generated by a bird hitting an aircraft varies with the mass of the bird and the square of the speed of impact. The more significant factor is the speed, so pilots should slow down if possible. The same is true of engine speed. So to minimize engine damage, RPM should be reduced if there is time to do so, and speed and phase of flight permit. The density of the bird is also a factor in the severity of damage caused. To sum up the foregoing, the collision speed is the most important factor in birdstrike damage, followed by the mass of the bird. Aircraft and engine speed reduction can thus reduce potential damage. In the early days of the use of jet and turboprop engines, there were several serious accidents involving engine damage, and it was realized that engines and other forward-facing components, such as windscreens, had to be more impact-resistant. Improvements in fan blade design and materials made it possible to build engines that could take the impact of a 4-pound bird and be shut down safely, which is now the regulation industry standard. This resistance to impact standard is also applied to other parts of the aircraft. For most areas of the airframe, the 4-pound standard applies, but the empennage or tail unit must resist an 8-pound impact. Despite these improvements, multiple birdstrikes are capable of disabling engines and other aircraft systems. The best-known such incident in recent times occurred in January 2009, when an Airbus A320 of US Airways, departing from New York's LaGuardia Airport, hit a flock of Canada geese at 3,200 feet and lost both engines. Unable to glide back to either of the airports in the vicinity, the captain, a safety expert, glider pilot, and a former fighter pilot, made a successful landing on the Hudson River in a brilliant piece of flying. All 150 passengers and 5 crew were safely rescued from the floating aircraft. Since 1980, ICAO has operated its Birdstrike Information Service, or IBIS, to record and collate data on bird strikes. In the first 15 years, over 62,000 strikes were recorded, and the system continues to amass data on the effects of bird activity on aircraft in order to improve prevention measures and reduce the number, risk, and cost of bird strikes. Under EU OPS regulations, any bird hazard or actual bird strike must be reported immediately to ATC. If a persistent hazard is apparent, it can be retransmitted to other aircraft or added as information in the Automatic Terminal Information Service or ATIS broadcast if the airfield has one. Regular and expected passages of large number of birds, as occurs at migration periods, would be notified in bird NOTAMs, or bird TAMs as they are known. Despite all the preventative measures, bird strikes will inevitably still happen. In the UK, it is mandatory to report them to the Civil Aviation Authority, whether or not damage has been caused, and even if a bird strike only becomes apparent after flight from evidence on the airframe. A written report on the appropriate form, depending on location, must be completed after flight, giving such information as aircraft operator, type and registration, airfield and runway, weather, height and speed, phase of flight, damage, effect on flight, and number and species of birds if known. Bird remains can even be submitted for identification if the species is not recognized. The CAA Birdstrike Occurrence Form, Form CA1282, is available online, and the information submitted helps to add to the knowledge base and thus improve bird strike prevention measures. In summary, it can be said that while the risk of bird strikes and the damage caused can be much reduced, and bird populations around airfields managed to a certain degree, there will always be a risk of birdstrike, as it is impossible to regulate wild creatures, particularly in 3 dimensions, and bird strikes will continue to happen. Thorough training in emergency procedures, both of aircrew and ground staff, can mitigate the effects of a serious bird strike, and accurate reporting of incidents can help in devising techniques and procedures for prevention.